example from page 425 about a football team having a banquet and how much it would cost. So there is a base cost, which is probably the cost for the hall rental, and then it's $20 per person. So N represents the number of people attending the banquet. So they've given us this formula, and they've asked us to make a table of values for a minimum of 100 and a maximum of 500. So I started to fill in the minimum of 100, the maximum of 500, and then I tried to choose about even intervals in between. And it didn't work out perfectly near the end, but it's close enough that we are going to be able to see the trends. So those are the N values I've chosen, and if I'm looking for my C values, then what I'll need to do is fill in the value for N. So the first one I have is 100. And if you put that in your calculator, you're going to get 2,500. So that means that if you invite 100 people to the banquet, the cost of this is going to be 2,500. And I can do that with all the rest of the values as well. So I've substituted all of my N values, and these were the C values that I got out in the end. So I've plotted all the points from the previous section on this graph here, and there's 8 points here. There can be two arguments made as to whether we should actually join the dots. Strictly from a discrete or continuous perspective, we should not join the dots because you can't have a fraction of a person. So it's not like every value in between of these exists. Some people, though, would argue that you should be able to join the dots because even though the data is technically discrete, because there are 100 people between here and here, there are really so many points in between there that it makes sense to at least draw a trend line. So I can see it from both perspectives, but for the time being, I am not going to connect the dot. A more interesting question is part C over here, where it says, if all possible ordered pairs were plotted on the grid, state the domain and range. So they're not asking for the ones that I actually calculated and plotted, they're asking for all possible pairs. So if we're just looking at N, what we're asking for is what are the possible values of N? So remember that N is the number of people coming to the banquet. So that, like they said, you would have a minimum of 100 people and a maximum of 500 people. However, you cannot have a fraction of a person. So while the number 101, 102, 103 are allowed, you cannot have 101.5. So when we're listing all of the values of N, we don't actually want to say that all real numbers are allowed in this case. Certain real numbers are allowed, and as a matter of fact, those real numbers, you can either state that they are an element of the naturals, the whole numbers, or the integers. So I'm just going to say that N has to be an integer. In other words, N has to be a whole number between 100 and 500. So when they're asking about this idea of restrictions, restrictions means that there's certain elements of the domain and range that have to be specifically tailored to the word problem. So the word problem already told us that N has to be between 100 and 500. So that is a restriction. Another restriction is that in the context of the word problem, N has to be an integer. So both of these are restrictions on N. If N had no restrictions, we would say that N is an element of the reals, but it isn't because of the way that the word problem is set up. When we're thinking about the range, again, there are restrictions on it because the range represents the possible costs of the banquet. So when we do know that if we start the minimum number of people at 100 people, we're going to be paying a minimum of $2,500 for the banquet. And we're also going to be paying a maximum of $10,500 because that's the maximum number of people we're going to be paying for. So we know that our C value, our cost, is going to be between these two values. But what about the values that exist in between? It is not possible for the value of the cost to be $2,500.50. It's not even possible for it to be $2,501 because if you refer back to the formula, we're paying $500 as a flat rate and $20 per person. So actually, our price is only going to go up by intervals of $20. So for example, we could have $2,500, we could have $2,520, we could have $2,540 and $2,560, but not the values in between. Now, for the purposes of grade 10 math, we don't have a fancy way to write that. There are fancier ways you'll see in higher maths, but for now, I would say that it's okay just to say that C is in multiples of 20. And that would be sufficient for you to write it that way. And there is our range. So in conclusion, even though we have a formula like this, which in theory it's possible for you to plug negative numbers in here, decimal numbers in here, and they would come out to real numbers, the problem is that when you have a real word problem situation, you have to consider the domain and range that makes sense for the word problem. For example, we're not including negative people, fractions of the people, or any amounts of money that are not multiples of 20. So when you're writing the domain and range for a word problem, you really have to consider the context of that word problem and what would make sense.